Today I went over and watched some of the pre-lecture videos for chapter 25, which included electric current. I watched videos from Organic Chemistry Tutor, and what this essentially is, it's just saying that current equals charge over time, and then you also have Ohm's law, which is V equals IR. When I goes up, V goes up. When R goes up, I goes down. And then it got into power equals VI, which equals IR times I, which equals I squared R, which equals V squared over R. And then a practice problem where if current flows for 12 minutes, how many current, how many electrons, etc. So then got into some of Kirchhoff's voltage law, which is pretty much just saying like direction of current and how that affects electric potential. And we have a couple practice problems down here. So if you have a battery that gives 12 volts, it runs through a resistor and the current. So I have 12V minus 8I minus the 10 resistor times the current, etc. And it should all equal 0 by the end. And essentially you use the V equals IR. So you just add up everything and it gives you a total current of 0.4 amps for this problem. Same thing for this one, except since everything's in series and there's also an extra battery, you just add the 8 plus 12, and then eventually, same process. Also went over some RC circuits, which is the time unit. So with a capacitor, you use this formula right here, or V, this is your desired EMF, 1 minus e to the time constant over RC. So you have your time constant and RC, and your time constant will net you these values, and then you can use that if you plug in 7.58 right here, 1 minus 1, which is just RC over RC. So 1 minus e gets you that, and then you can reverse it to go back and get your time constant, which is what you do down here. Then I worked through some of our homework. So there's a current density problem, which is just J equals I over the cross-sectional area. So our current over cross-sectional area gets a current